Hey y'all, we're back out here to the heat pump, and we're going to perform another little test out here on my American Standard Heritage 13 SEER R22 dual fuel system here. I've got the thermostat pulling to heat right now. It's on a delay, so we've done several tests on this unit so far on the heat pump here. We've done the ambient and coil sensor test to make sure the sensors were good on the unit. We've actually done a defrost control board check where you can check the voltage on your defrost control board, and we actually did a forced defrost also. I think we did another video on how the refrigerant actually moves in this particular unit in the cooling mode and the heating mode. And today I'm going to shoot a little video on the coil right here on the reversing valve itself. And let me see if I can get in between here. As you can tell, I'm dealing with a tight spot. Fritz is a pretty big feller, so just bear with me here. Okay, y'all. So what we're going to do today is I'm going to go ahead and pull my fill piece to voltage. And as you can see, we're getting this 48.8 M reading on our voltage here. Well, that's not the true voltage that's supposed to be applied on this coil. This particular coil and this reversing valve here in American Standard equipment and a vast number of other manufacturers energize their reversing valves in the cooling mode, okay? So that means at 24 volts when it's called for a defrost, which is actually, you know, it's going into the cooling mode, or you're physically setting your thermostat to the cooling mode, it'll energize that coil with 24 volts, okay? And actually I'm going to show you what that looks like, and to tell if we're actually getting voltage here to the coil itself. My good buddy Eddie next door there, he's a heck of a computer tech, and he had like an old hard drive or something laying around, and he gave me the magnets out of it. They're not the best magnets to test this with, but those earth and ground magnets that I wanted to give a shout out to the furnace man, Jason. He actually has a couple of videos on YouTube here of the furnace man. His name's Jason, and I didn't want to I'm not trying to steal anybody's thunder here. I just wanted to perform a test, and I wanted to give my buddy a good shout out. He actually got those earthen magnets he said he purchased at Granger. He's actually got several videos on this reversing valve, and he did a fantastic job, and I just wanted to give him his props. So we appreciate it, Jason. Thanks so much, and I hope everybody goes and checks out your channel, buddy. But okay, well, getting back to our coil here, like I was saying, in the American Standard, this particular unit, it is energized. The reversing valve is energized in the cooling mode, and to do this, that's going to entitle us to actually go back and perform that test that we did a while back, where I energized the forced defrost pin and the common pin here, and that's going to put it into the cooling mode. The fan will stop, the reversing valve will slide, and you'll actually be able to see these magnets slide over here to this side. And what it's actually doing is it's actually letting this discharge line flow directly into this your outside coil, okay? Whenever refrigerant is flowing into the outside coil, you're in the cooling mode and on a heat pump. And whenever refrigerant is flowing hot gas into the indoor coil, you're in the heating mode, okay? All right, well, we've got our perspective probes, my alligator clips hooked to the perspective terminals on the coil here. So we've got that funky measurement here. Let's go ahead and hit our defrost here, okay? And that's going to be hitting this forced defrost pin in the common. There we go. Okay, 0 volts. All right, there's our 24. Fan stop. We got 24 volts. That was a key indication of the coil being energized and shifting that slide over to the cooling mode. All right, we're going to be in this position roughly for about 1.5 minutes, being it's on forced defrost. So, and look, here's your here's the I don't know if you can see them. Here's the magnets where the slide is slidden completely over, allowing the gas to go back through the outdoor coil to defrost it, or if you're in the cooling mode to start cooling the house. And all this actually is determining here is whether or not we have voltage applied to the coil here, okay? And we do. So what we're going to do is we're going to wait for that fan to kick back. It's probably going to take approximately maybe 30 seconds, probably less, for the reversing valve to de-energize. Keyword, de-energize. There we go. Fan's back on. Watch the 24. She's going to drop out as soon as you hear that, you know, that notorious sound we hear relating to the heat pumps here. Here we go. It should be right about now. Come on. There it is. Okay, 0 volts. Now we go back to the funky volts. Okay, and as you can see, our magnets have slid back over, and now it's allowing the discharge gas into the indoor coil here. Okay. All right, y'all. There's another test we can perform to easier test that we can perform to ensure that this coil is good or bad, and this would be this would tell you whether or not you have to replace the coil or not. Okay. Let me get my stuff together here, and I'll show you that next step. Okay, y'all, just for giggles, we're going to watch the magnets. We're in the heating mode of the heat pump here, and I'm going to force another defrost, and let's watch the magnet slide. We're going to hit the defrost, force defrost pin terminal in the common terminal, and once the fan kicks out, we should see the coil energize, and we'll hear that, you know, that notorious, and we'll watch the magnet slide. Here we go. All right, y'all. Ain't that something? There she goes. All right, y'all. That's all there is to it. It's going to be in this position for approximately, I don't know, minute and a half or so. And like I said, we got our 24 volts here coming off our coil, being that it's energized. It has energized into the cooling mode. Now when it de-energizes, the voltage will knock out and you'll get that funky measurement. But anyway, this is just showing us, like I stated, that we're getting 24 to the coil. So let's watch your slide back here in just 1 second. Should hear the fan kick in 1 second. And we're going to de-energize right now, and we're going to go back into the heating mode. Fans on. You should de-energize in any second. And there she is. That's what it looks like with the slide sliding. That way we know we have the slide is mechanically sliding. Okay, y'all, let's do that other test I was telling you about to determine whether or not we have a bad coil here on top of our reversing valve, and whether or not it needs to be replaced. What are you doing up there? Huh? You getting after him? Come here. Say hey to everybody. Say hey, Ray. Hey, Dallas. Hey, fellers. Okay. Ham it up, boy. All right, kitty cats are coming. Look, they're next door now. I see them. All right, y'all. What we're going to do here now is we're going to do that simple procedure I was telling you all about. This will delegate whether or not you have a bad reversing valve coil here. And what we've done on this procedure is we've removed power to the unit. I've got my disconnect out. I've actually went inside and I've turned it off at the stat. You can turn it off at the switch or whatnot. But anyway, we've got the my probes, my alligator clips hooked to the prospective terminals on the coil here. As you can see, we have removed one wire off of it. All you got to do is take one wire off. You don't have to disassemble anything to do a resistance reading here. So what we're going to do is we're going to set our fill piece SH35 to ohms here, and we should be having some resistance, and we do. And that's telling us basically the coil's good. We do have resistance. If we had an infinite reading, that means the coil would be open, and it would mean it'd be time for a coil replacement. All right, y'all. Hope y'all got little something out of the video and all, and I appreciate y'all watching. I really enjoy getting out here and fooling around with the heat pump a little bit. So hope y'all got something out of it. I know I did. I reckon I'll holler at y'all soon. Thanks for watching. Take care.